So what we have loaded here is VisualCADCAM. You'll see that it looks exactly the same as in Rhino. You have the machining browser over here, the object browser down here. Everything works exactly, virtually exactly the same. And I have a 2D drawing of that part, okay? And no 3D model. So you can program this just by using the geometry that we have in the drawing. What I recommend you do if you are going to do a 2D drawing, just get out a pad and paper and just do a little sketch of your part. Identify what levels that you're going to cut to. So that's going to be the really important part. You know, how deep are you going to cut? Yes.
Hey, Don, there was a question about difference between Rhino and VisualCAD. I just wanted to mention, Rhino obviously is a very powerful CAD system. Not only does it include a modeler, but it has other additional tools like programming and scripting and things of that nature. So if your shop needs something some system where you need a lot of horsepower for 3D modeling and even 2D modeling, we would recommend using the Rhino and Rhino CAM combination.
Yeah.
It's a really powerful combination.
That's actually the best.
Yeah. But if you're just bringing in 2D geometry, DXF files and things of that nature, if you're working on, parts nesting, simple parts nesting, or laser machining, flat geometry, then VisualCAD will be more than sufficient for you. VisualCAD is not it's not targeted at modeling per se. It's more targeted to shop floor programming and to make it real easy to use. So that's the primary difference between these two products. The CAM portion itself is identical, like Don was saying, pretty much identical. There are some certain things in Rhino CAM you can do. For instance, API, we can use an API for advanced, programming, things of that nature, but that's not possible in VisualCAD. But for programming, manual programming, the systems are pretty much virtually identical. Thanks,
Okay.
Don.
Okay. So we got the 2D drawing. Let's go back up to the top view. And it's really good to have your curves merged because we are going to have to select geometry here. We can't do anything automatic with this. We can't use any 3-axis operation because there's no surfaces. We're limited to 2-axis programming, which is fine for doing this part. But I'm just going to take these curves and I'm going to go to the curve modeling tab real quick and I'm going to merge them. Okay, so as you see, it's one curve now. Okay, and I'm going to do the same thing over here on these curves right here. Okay, so now we have a curve there and we have a curve there. Good. And then also, I don't think we're really going to need that. That's all one curve. That's good. Okay, so we're going to approach this differently than in the 3D model. So we're going to go ahead and the machine portion is the same. Post is the same, setup is the same. Currently, our work 0, as we mentioned in Rhino CAM, the work 0 is at your world coordinate system. Let's go ahead and create a stock. Take a box stock. And if you do the copy model bounding box, it'll snap to the, the box the perimeter that we have drawn there already. And because I'd already worked on this model already, it automatically put a height of 17. And that happens to be the actual height of that other part. So it's the height is set to 17. We'll just pick OK. So now we got our stock model, the same as in the other in Rhino CAM. And we're going to go ahead and put our work 0 at the top, southwest, in the same point. Okay, so now we have the work 0 like we had it in the other part. And for this, we're going to be doing two axis operations. We're going to do a pocketing and then a facing for this open pocket right here. So let's go ahead and do 2 axis. We're going to go pocketing. For the containment, again, as I mentioned, anything you select here will contain your toolpath to that area. So we're going to do the select curve edge regions. We're going to pick this region that we merged, and that's where the pocket's going to be. So for the tools, we don't have any tools. Let's go ahead and we'll just create a 6mm tool like we did before. We'll just save everything else. We'll save that as a new tool, exit. So we got a flat mill, and we're going to use all this is going to be the same. With the cut parameters, it does leave stock. Okay, we'll leave that for now. All of these parameters, we'll just leave them set to the default parameters. This is the critical tab, cut levels. Because it's only a 2D drawing, it doesn't know how deep you want to cut. Okay, and it doesn't know where to start the cutting. It only knows that it's going to contain it in this area. Okay, so we're going to tell it where to start cutting and how deep to cut. Okay, so you'll see this option here, location of cut geometry. Well, we don't want to cut where it's at because this is the bottom of the part. So your geometry is not at the top of the cut, and we don't want to start cutting at the bottom of the cut because that's not the bottom of the cut. Okay, so we're going to use this option here called pick top. And by doing this, you can tell it where to start cutting. So I know my part is 17mm, so we're going to start cutting at 17mm from Z0, okay? And we know that the depth, I got a little sketch here, the depth is 13.1. So for the total cut depth, we're going to set it to 13.1, okay? So when you do that, you'll see that the rough depth is set to 13.1. The rough depth per cut is set to 13.1. With these parameters right here, it's only going to do one cut level at the bottom of the pocket. Now, if you noticed in this other one, we had multiple cut levels. Okay, so we're going to do multiple cut levels over here. So we can use this slider just to adjust how many cut levels you want. And this is an estimate of how deep each cut level is going to be. So let's go ahead and we'll just use that. We'll just go use that. We'll do some arc fitting and generate that. So you'll see here that we have, okay, so that's cutting at the top. So that's not what we wanted. Let's go back into here and cut level started at 17, depth. I'm not sure why it went up there. Let's see here a second. It should have started up there.
Yeah, are you sure 17?
Yeah, it's the top of the stock. So it should have been up there,
well, because
but
you had it at the bottom. Because you said, I think it's better to specify it's at the bottom. Because what's it saying is that, yeah, and then it's going to move it up by 13.1.
Oh, I see what you're saying. Okay. Yeah. Okay, so at the bottom, a depth of 13.1. Let's see what that looks like.
Yeah, that's what you want.
Well, that's putting it all the way through. No, let's just simulate that real quick. Yeah, that put it all the way through. Let's debug this real quick. The cut levels, it should have put it at the top from here. It looks like it was putting it from here up and not from here up. You understand what I'm saying, Joe?
Yeah.
Let's go ahead and change
So
that.
what is the height of your stock model?
17.
Okay, for the purpose of this demo, just move the other part, the geometry up by 17.
Okay, yeah, we can do that. Let's go ahead and turn the stock off. Let's turn our triad on. Let's regenerate that. See what happens.
At top, you need to pick at top.
Okay.
Yeah.
Okay. Let's simulate that. Okay, there we go. And this is a good example. You know, doing it from a 2D drawing, you got to know what your dimensions are. You got to anticipate where the cut's going to start, where it's going to end. So there's a lot more steps involved in doing it in a 2D drawing. This is why, if at all possible, use a 3D model, because all of this information is automatically in the model and it understands that. Okay, so let's go ahead, and we got that pocket. Let's go ahead and do a facing real quick. Let's see, about 12 minutes left. Let's do a facing, and we're going to remove that. We're going to use this. Okay, same tool. Okay, all that's fine. Cut levels at top. The depth again is going to be 17. Total cut depth is 17.
13.1, I thought.
Oh yeah, 13.1. You're right. 13.1. Okay. And okay. Okay, let's go ahead and see. Okay, there we go. And again, I'm not going to do the holes, but doing the holes is the same procedure. So, is there any question on that, Joe? I know it was kind of sloppy there at first. Anybody got any questions on that?
There was a cut start point question on the pocket for pocketing.
Mm-hmm.
And what your question was, well, it started on the inside. That can be changed. I mean, if it's a pocket, we do it by default. It starts in the beginning. I'm sorry, in the middle of the part or inside the part, but that can be changed if you want to start it from the outside. And we can also specify start points as well in pocketing. So.
Mm-hmm. Let's see, outside. There's an option right there.
Yeah.
So it gets closest to the perimeter as it can. There's not a whole lot of room in here for the part, so you may not see a whole lot of difference, but it is starting right here on this outer edge right here. Okay, it's starting right there actually, right here. You see that? And as Joe mentioned, you can select the start point or define the start point.
And the question was, it started below the top of the geometry selected. Yes,
Mm-hmm.
it will start below the top because you're specifying that it's safe to cut. If you go back to the cut levels, you're saying your cut level 13.1 or 2.62 is your depth of cut. So from the top of your stock is at 0. And so the first cut level will start at 2.62 below that top, because you've already specified to the system that it's safe to cut 2.62. So it's being efficient that way. So hope that makes sense.
Yeah. Yep. And again, with a 2D drawing, you need to work out all of these cut levels worked out in your mind. If you have to, just draw a little sketch on a pad of paper, identify the different cut levels and how deep each operation is going to cut and where it's going to start and where it's going to stop. More complicated than a 3D model. That's why we highly recommend do a 3D model if you have it.